Good morning, class. This is yet another time we have a lesson, and we're going to have a lesson in mathematics. I want to welcome you so that we can be able to learn together. You have learned, I believe, very many aspects of mathematics, but I'm particularly going to talk about volume. Volume. So, when you hear the word volume, what comes to your mind? Perhaps I may be able to define that as, volume is, the volume of a shape is about the size or the measure of the size that it occupies. The measure of the size that it occupies, both inside or even outside. When you place it somewhere, how much space does it occupy? Okay? So, we are going to particularly look at the volume of a cube. Volume of a cube. A cube is a six-sided square-shaped material. Six-sided square-shaped material is a cube. It has the shape of a square. That means that all the sides are equal. This is a cube. When you talk about volume, we will be talking about this part of the cube, this part of the cube, and this part of the cube. These will help us be able to determine the volume of the cube. In this case, this is what you call the height. H, standing for height. And this is what you call the width or the breadth. Width or the breadth, they can be able to be used interchangeably. And this is the length. The length. What comes out is that in a cube, all the sides are equal. The height, the width, as well as the length, they are equal. None of them is more than the other or smaller than the other. So what is the formula for getting the volume of a cube? We write volume is equals to height times width times length. Although I know you have been taught before, it is length times width times height. There's nothing wrong. It means the same thing. It means also base area times height. Base area times height. That is length times width. Once you get this area, then times the height. These will give you the volume of this cube. So let's give it some value. If, for example, we are asked to find the volume of this cube, this side is 6. Definitely this side is also going to be 6, and this side is going to be 6. 6 centimeters, 6 centimeters, and 6 centimeters. So our volume will simply be, we write the formula, length times width times height, and the length is 6 times width 6, and then times height 6. 6 times 6 times 6 is going to give you can be able to do some very simple calculations very fast. 6 times 6 is 36. 6 times 6 is 36. And then 36 times 6 is going to give you, this is 36. This is 18 plus 3 is 21. So our volume is going to be 216 centimeters. And which unit do you write them? Cubed. centimeters cube. That means 1, 2, 3. That's why we say cube. This is volume of the cube that we have here. 6 times 6 times 6 gives you 216 centimeters cubed. You can use this formula in working out all sums pertaining to cubes and you will never go wrong. Now, in KCPE, sometimes you are not given a sum like this and given the units as we have indicated. Instead, you are given a block where a block is made up of several cubes, and then you're asked how many cubes are missing, or how many more cubes should be added here, or how many cubes are contained in this block. You need to just count because all those cubes are of the same size. Then you can be able to determine how many cubes are there. So essentially, you will need to be keen enough in counting the number of cubes that are there to determine what makes up the entire block that you've been given. Are we together that far? So this is as far as getting the volume of a cube is concerned. Now, I will give you some assignment on getting volume of cubes, but particularly I'll give you one which requires you to count the number of cubes. For example, we could be able to, let me just give it So you could be asked, how many cubes are missing in this diagram? You realize this section here, some part of it is not there. We have some 2 cubes that are missing from this first row, second row, third row, and even the 4th row. So you need to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You find 10 cubes are missing. And how many cubes are there altogether? 1, 2, 3, 4, 5, 6. You just count 1, 2, 3, and then times 1, 2, 3, 4. These ones are 12 cubes on this column. Another 12 cubes on this column. That means 12, 12, and here we have 12. But here we have 1, 2 times 4. That is 8 on this column and 8 on this column. So in total we have 8 plus 8, 8 plus 8 plus 12 plus 12 plus 12. This gives you 16 plus 24 is 40. 40 plus 12 is going to give you 52 cubes. So this block is made up of 52 cubes and 10 are missing. So if you are to make it complete, you would have 62 cubes if it is complete. So you will have to encounter with such sums, and more particularly the ones that I'll give you the assignment on, where you are required to count the number of cubes. Just count. Like in this case, if you are talking about this column, this would be 1, 2, 3, 4, 5, and then times 1, 2, 3, 4. This would be 20. And then this one would also be 20. And here, because some are missing here, they cannot be 20. They will be less 20. Of course, 20 less these ones that are in between. But in total, you'll find that they end up being 62 cubes. That is if we are going to add plus the ones that are missing there. So boys and girls, that is just simply how you can be able to find the volume of a block like that, which is made up of cubes. Cubes, remember we said these are shapes which are six square-shaped figures which come looking like this. They are all the same size and they have the same volume as well. So remember the volume. The formula is base area times height, length times width times height. Then the measurement is done, and then when you write that, of course, you make sure you include that the unit, the sign cubed, meaning that is volume. Now, I want us to talk about the volume of cuboids. The volume of cuboids. How do you find the volume of a cuboid? Now, unlike the cube, which is square-shaped, which is six-sided square-shaped figure, the cuboid is six-sided rectangular-shaped figure. Six-sided rectangular-shaped figure means that some sides are not the same as others. As you can see, this is the height, this is the base or the width, and this is the length. The length is much longer than the width, and it's also much longer than the height. It doesn't come always that way. Sometimes you may find the height being longer than the width, or the width being longer than, of course, the length will always be longer than all of them. So, to find the volume of the cuboid, we will not apply any other different formula. We will use the same formula. Volume equals base area or length times width times height, which we said is the same as base area times height. Once you've written that, then you look at the units used. Like in this case, if we were to give our figure some units, this is, let's say this is 2, this is 4, and this is 10 centimeters, centimeters. Now, volume would be length times width times height, which is 10 times 4 times 2. And 10 times 4, of course, is 40, times 2, it's going to give you 80. So the answer is going to be 80 centimeters cubed. 80 centimeters cubed. This is how simple it is to find the volume of a figure, and I want to believe you can be able to do that at the comfort of your, wherever you are, without any much struggle, because it is just very direct. Perhaps one may be scratching his or her head and asking, what about if it's a figure that is not just a cuboid, but it has other shapes? For example, it could also have a triangle on it. How will we talk about that? But before I talk about that, let's take this other shape and see how it works. Looking at a shape like this, say this is 10 centimeters, this is 8 centimeters, this is 6 centimeters, and then this is 5 centimeters. Is it possible to find the volume of such a shape? Of course, the answer is yes. It's very easy. We can use two different methods or two different approaches in finding volume of this figure. The first approach is we can divide it into two. We'll divide it into two. so that we have two cuboids. We have cuboid A and we have cuboid B. Having divided it that way, then we can say volume A, that is volume for cuboid A, would be length times width times height, whereby the length would be 5 centimeters. Sorry, I think we need to make this 5. This is 5 centimeters and this is 8 centimeters. So the length would be 8 centimeters times the width, which is 5 centimeters, times the height, which is 10 centimeters. Now, that means it's going to be 8 times 5 is 40. 40 times 10 is going to be 400. So our volume is going to be 400 centimeters cubed as far as volume A is concerned. Then we go to volume B. Volume B. We check, do we have length? Do we have width? Do we have height? Yes, we have length, which is 8 centimeters, times the width, which is 6 centimeters, times the height, which is 4 centimeters. So the volume is going to be 8 times 6, which is 48. 48 times 4, you could work it on a rough paper somewhere, times 4, this gives you 32. 16 times plus 3 is going to be 19. So this is 192 centimeters cubed. That is for volume B. Then at the end of the day, you now take it as total volume. Total volume is going to be A plus B, which is 400 plus 192. Sorry, 400 centimeters cubed. Now, the total volume, therefore, is going to be A plus B, which is 400 centimeters cubed plus 192 centimeters cubed, and that adds up to 592 centimeters cubed. That is the answer, the volume for this figure that we see up here. Do you find it very easy, boys and girls? Sure, it is just that easy. So you can find volume of a figure like this, which is taking two shapes, that is two cuboids combined together very easily, like we've done. Remember, we subdivided that very easily so that we can be able to find a particular shape. This we can find its volume, and then we can also find this volume very easily. It's not easy to find the shape, the volume of this figure without subdividing it as it is, because then you cannot be accurate enough to tell what measurements are on some parts which have not been indicated. So this is how you are supposed to do it. Break it down, and then you'll be able to get to the volume very, very easily. I want to believe you have acquired some skill that can help you be able to attempt any question given to you as far as volume is concerned. I can now also talk about volume of a different type, a different shape, so that you also have a look at it and see if you can be able to attempt it. What about if you're given a shape like this? Is it possible to find volume of such a shape? Yes, it's very possible. Let's imagine this is 2 centimeters, this is 3 centimeters, this is 10 centimeters. To find volume of such a shape, you will still do the same thing as we did here, because these are two shapes together. We subdivide this. Now we have two shapes. We have a triangular cuboid and we have a rectangular cuboid. So these we shall call it A and these we shall call it B. Using the same formula, we shall say volume A is going to be length times width times height, whereby length is 10 centimeters. Sorry. We could have this as 8 centimeters, 8 centimeters here. 8 centimeters, it will help us a lot. So we have 8 centimeters. 8 centimeters times 3 centimeters times 2 centimeters, which is going to be 24 times 2, which gives you 48 centimeters cubed. And then volume B is going to be length. This is now a triangular prism, a triangular cuboid. We will not use the same formula. Rather, we're going to say a half times length times width times height. Remember the area of a triangle. How we find the area of a triangle? We do it as a half times base times height. So here we are going to have it as a half times the length in this case is 2 centimeters, because if this is 10 up to here is 8, that means this is 2. So we're going to have it as 2 times the width, which is 3, and then times the height, which is 2. So that way we're going to have it, we cancel 2 and 2, and then we are now left with 3 times 2, which gives you 6 centimeters cubed. So the total volume is going to be volume A plus volume B, which is 48 plus 6. This gives you 54 centimeters cubed. 54 centimeters cubed. Boys and girls, I believe that can help you a lot in determining the volume of a cube and the volume of a cuboid without much struggle. So, having done this, I want to believe you should be able to attempt the exercise I'm going to give you without any much trouble. But should you find any trouble, be sure we will be going through this in the next lesson, and we'll be able to help you understand much more. Thank you very much, and may God bless you.